Okay, it is November 23rd, 2016, and this video is my attempt to fix some hardware defects with some of the Dexter boards that I had made but I have not been able to sell. So what you see here is a working Dexter board, and then off to the side I have a non-working one, and the problem with this one is that the microcontroller that's right here, for some reason I can't program it. And the way that programming works is this device, which is called a Dragon, it's basically either a programmer or a debugger for these AVR microcontrollers. It connects up to the pins right here, which are these, and 3 of the pins on here are how the programming takes place. So there's a ground pin, a 5-volt pin, and then 3 of the pins handle the programming. And here, I'm going to pull up the schematic. So ground, 5-volt. Oh yeah, there's also a reset. There's a reset pin. And then this MISO pin, MISO, and SOC, S-C-K. Those 3 handle the programming. So normally, you can do things like read from the microcontroller using this program. You can like read fuse settings, you can read lock bits, you can read what's on the device. You can just make sure it's answering or it's communicating properly. So that's what happens on a good one, but when I hook it up to this one that's not working, I get an error. So I think the first thing if I was really desperate, the first thing I would probably do would be I would check these pins right here. The first thing I would do would probably be to check the 3 pins I just talked about and see if any of them are accidentally soldered together, or accidentally soldered to 5 volts, or accidentally soldered to ground. But I think I already checked that before and I didn't see any evidence of that. And I looked at the schematic, and unfortunately these are pretty much directly connected right to the microcontroller here. So worst case, I would say the worst case scenario is that this microcontroller is bad and needs to be replaced. And it's quite a pain to not only desolder this from the board but then solder on a new one, because I believe it has 40 of these pins going all the way around. So it's also kind of risky to solder on a new one because I have to use the heat gun, and every time I do that I risk damaging the new replacement part, or I risk damaging the board. So I prefer not to have to desolder this. So I'm going to try to kind of prove to myself that the problem is with these pins somehow. And the way I'm going to do that is I'm going to hook up my scope to the pins on the working board and see what proper behavior is supposed to look like. Then I'm going to hook up the scope to the pins on the non-working board, and hopefully I'm going to see something different. And hopefully by seeing something different, I'll be able to figure out where the problem is. So I'll be back with the results of my findings. Okay, I've discovered something here. This shows the 3 pins I was talking about with on the board that has the problem. So you'll notice that the blue pin, here, let me check my notes. The blue pin is the blue pin is SCK. The yellow pin is MISO, and the pink one is MOSI. So you can, so this one's MISO, this one's SCK, and this one's MOSI, right? Yeah. So as you can see, SCK and MOSI are changing, but MISO is not changing at all. So then I swapped out the bad board, put in a good board, and this is what was different. So here's MISO, here's SCK, and here's MOSI. These two are still kind of acting the same, sending some information here. But after they're done sending their information, then the MISO drops, goes low, to indicate maybe receipt, successful receipt of a command. So on the bad board, the MISO stays high. On the good board, it goes low. So then I decided what would happen. Then I decided to measure what would happen if I just unplugged my programmer. And here's what happens. If the programmer is not plugged in, then the MISO pin is low. The SCK pin is also low, and the MOSI is high. But on the bad board, it's kind of opposite. The MISO is high, and the MOSI is low. So the next step is to kind of look at, well, there could be a few things that could be causing this. So I need to look at everything that's connected to those pins. So I'm going to pull up. Let's check the MISO first. Come on, there we go. So the MISO is connected to the main microcontroller as we expected. It's also snakes through here and comes all the way down here and is connected connected down here on the LDV1000 connector, but it's always pulled. It seems like it might be pulled high. I'm not sure. And if there was a solder bridge to ground right here, then it would be pulled low. Let's see what this one is. This one is another pin on the microcontroller, and also a pin over here on the DB25. So it's possible there's a solder bridge between these two, although I can just take out my multimeter and check for that really fast and prove that it's probably not that, because these are pretty big connections, but it could be something like that. So this is kind of the one that I'm thinking has a problem, and it kind of looks like the only thing it's connected to is the microcontroller and this. So that's kind of disconcerting, because that kind of suggests that the problem really is the microcontroller. Let's see what's nearby these pins. Here's the MOSI, which is kind of behaving strangely. And here is the SCK. Okay, so they're all next to each other. So the fact that they're all next to each other kind of tells me that there's probably not a bridge problem right here. Because if there was, then I would see, like, the scope would show them making the same signals. But I'm not really seeing that. Although I suppose it's possible that the MOSI and the SCK are connected, but they're not really next to each other. So I don't really think it's likely that they're connected. Okay, so there's something else on this board that's kind of interesting, and that is that the SCK and the MOSI are also connected to this LED driver over here. So when you program the board, all the LEDs on the board flash. But after the board's done programming, then the microcontroller can control this LED controller and cycle the LEDs. So I'd like to say that I think maybe this LED controller could be causing the problem, but it's possible. So I wish I could deduce, like eliminate what I don't think is causing the problem, but based on what I'm seeing right now, the problem could either be this LED driver causing problems, the main microcontroller being bad, or these pin headers up here being bridged. But I think it's pretty unlikely that these pin headers are bridged, because I can quickly determine that just by doing using a multimeter. So I'm going to go ahead and do that, but I think it's pretty unlikely. So based on process of elimination, I think the problem is going to be either this or this. I have 8 of these boards that have this problem, so I think probably all 8 of them have the same problem. So it's either going to be this one or this one. Since this one is harder to remove and solder back on, I'm probably going to take this one off first and see if the problem gets fixed. But I kind of think it's probably going to be here, because when I was messing around with the bad board and trying to program it, I saw the LEDs cycling properly. So kind of think this is probably going to be good, but I'm going to take this one off first because it's easier to replace. I have like a 50-50 chance. And then if taking this one off doesn't fix it, then I'll have to take this one off and put a new one on. And if I put a new one on and it's still not fixed, then I have no idea what the problem could be. So I really hope that replacing both of these will somehow fix the problem, and I hope that the problem turns out to be over here, but my instinct tells me it's got to be over here. So I'll go to work and come back and report. Well, bad news. I went ahead and removed the LED driver right here, and the problem is not fixed, so I'm forced to conclude that the problem is with the microcontroller itself, and it will need to be replaced. So that's what I'm going to try next. If that doesn't fix it, then I'm going to be very, very stumped, but not defeated. So I will do the work and report back. Okay, before I remove the microcontroller, I realized something, and that was that I wasn't quite satisfied with the way I was testing these pins. And so I got out my logic probe, and this is the working Dexter, and all those 3 pins that I was talking about, they are all floating if the device is erased. So I erased this device and tested all the pins. They're all floating. You can see the LEDs moving around as I touch this. That's because, as I mentioned before, these 3 pins are connected to this LED driver IC. And the microcontroller will control these pins after it's finished being programmed. Anyway, so on the bad Dexter board, this pin on the corner is always high, but on the good one it's just floating. It's not being controlled at all. So, not really sure what that means. Maybe it'd be helpful if I learned how this protocol works. It's actually very common, very standard, so it's probably really well documented, but I'm just observing what I'm observing, and all these pins seem to be floating. So I'm going to poke around a bit more on the bad board and see if I can find what's pulling this high. It could be that the microcontroller is just bad and that's what's pulling it high, but hopefully I can find something. Okay, I feel kind of like an idiot that I didn't catch this before, but this bad pin that's always high, it is actually tied to VCC 5 volts somehow. Like it's short-circuited to 5 volts. So, I think I tested to make sure it wasn't short-circuited to its neighboring pins, but I don't think I never tested to see if it was like short-circuited to 5 volts, and it looks like it is. And I don't know if you can see this without, my camera's probably going to go out of focus, but there's this blob of solder right here. So I'm wondering if underneath this pin header there's like a solder bridge, because this seems like unusual to have this blob of solder. So I'm thinking this part was actually soldered on by professionals, by the company that made the Dexter boards. So I wouldn't expect them to make this kind of mistake. But I think I'm gonna desolder this part, or maybe what I'll do is like throw some flux right here and take my solder wick and try to suck this solder out and see if that like fixes it. Because if that's all it is, then I won't have to remove this, and I can just reinstall this guy, the same one I took off. I didn't throw it away, I just took it off, but I can put it back on. So hopefully that's what it is. Okay guys, I think I figured it out. If you see right there, there is a huge blob of solder going across these two pins, connecting 5 volts to this MISO, which I have no idea how that got there, but it looks like the guys at the factory made that mistake. So I'm really hopeful that all of my boards, all 8 of my boards I have that won't program, have this exact problem, and then I'll just use my trusty desoldering gun here, and hopefully be able to remove all these without damaging them too much, and then resolder them and be good. Okay, so in conclusion, my last speculation on what was wrong and what the fix was seems to be correct, and now I can properly communicate with this device and program it. So a few thoughts I had. It's really unfortunate that I removed this because I didn't need to. Really fortunate that I didn't remove this, because it would be really hard to put back on. If I had removed this, I would have quickly discovered that these pins were still being, or one of the pins was still being pulled high even though there was nothing connected to it. And then I would have realized, oh well, it wasn't this, because this couldn't be pulling it high, this can't be pulling it high, and then I would have poked around and realized, oh, there's a solder bridge right here. So it's really unfortunate that I maybe missed this and didn't, I mean, I'm not really sure how I missed that there could have been a solder bridge here. I think my problem was I assumed that since it was professionally soldered that there couldn't possibly be a mistake there, so I'm like, it can't be that. Like, I was thinking it was more likely to be a bad component rather than a bad solder job, and that was my undoing. The fact that I got out the scope was maybe a little bit of overkill. I probably could have found this just by using the logic probe. So I probably didn't need to get out the scope, but I kind of wanted to see the voltage levels just in case. So I'm a little bit embarrassed at what the fix ended up being and how far off I was, but sometimes when you don't know what's wrong, you just have to kind of blunder your way through things and start removing parts off the board until you finally figure it out, and maybe you'll get lucky and you will find it fast, or maybe you'll get unlucky and it'll be the last thing you think about. So in this case I really didn't want to remove this, so I really wanted to like check everything I could before I removed this. Soldering this back on won't be that hard. I have some low temperature solder paste and a heat gun that'll put that back on pretty nicely. So I hope you enjoyed the video, and see you next time.